In this question, we will see how we can find direction of average velocity and average acceleration. So let me read this question for you. There is a particle which moves counterclockwise direction around a circular path. So this is particle which moves from P to Q along circular path in counterclockwise sense with constant speed. So this is the starting point, and this is the point where particle reaches. Now we have to find direction of particle's average velocity and average acceleration. So before starting this question, let me tell you the sign convention. If particle is moving towards right or particle is displacing towards right, then I will consider it to be positive. And if particle is moving towards left or if its displacement is towards left, then I will consider it to be negative. Similarly, if particle is moving upward, it will be considered as positive, and if it is moving downward, then it will be considered as negative. So this is the sign convention that we are going to follow. So first see what is average velocity. So average velocity is written as displacement upon time. That is final position minus initial position by time taken for this change. So this particle was initially here and finally it reaches point Q. So if somebody asks us what is displacement, so this is initial point, this is final point, so this is displacement. So displacement is negative, it is towards left. So displacement is negative divided by time, of course, it will be positive. So in this case, it comes out to be negative. So direction of displacement is negative, and therefore direction of average velocity comes out to be negative. So direction of average velocity, we know it is negative. It is like this. Now let us see direction of average velocity, and this is where most of the students commit mistake. So particle was initially moving like this, and at point Q, it was moving, but in downward direction. About average acceleration, we can say it is nothing but change in velocity upon time, which means V final velocity minus V initial velocity upon time taken. Time taken will be, of course, positive, but let me tell you what will be V final. So this is initial and this is final. Of course, speed is constant, but applying sign convention, since this particle is moving downward, I will say final velocity is negative minus initial velocity. Initially, particle was moving in upward direction. So as per our sign convention, it has to be taken positive upon time taken, which of course will be positive. So negative minus this is negative into positive, it again comes out to be negative. So overall, it will be negative upon positive, which again comes out to be negative, right? But here, negative implies this direction because here upward direction has been considered to be positive and downward direction has been considered to be negative. And since we are getting negative, it implies downward direction. So direction of acceleration is downward. So direction of velocity is left and acceleration is downward. So option B is correct. And let me tell you how I can justify this. Initially, particle was moving like this. And now I will apply force F in this direction. And by applying this force, I can make particle to move in this direction. So suppose particle is moving like this and applying force F here. So this force will first stop this particle. It will reduces its speed. Finally, velocity of this particle becomes zero. Then this force will move this particle in downward direction. Right. So if particle is moving upward and then it is moving downward, upward means in y direction. Downward means in minus y direction. So obviously force would have been applied, which should be in downward direction, that is towards minus y direction. And we know that F is equal to m into A. Whatever is direction of net force, that will be direction of net acceleration. So direction of force is towards minus y direction, and therefore I can say acceleration will also be towards minus y direction. So even I can justify acceleration will be downward. And if you are having confusion, let me tell you this particle is moving in xy plane because some students think that this motion is in vertical plane. No, it is not. The particle is moving in xy plane. In case of any confusion, you should know that normal reaction is getting balanced by mg force. So finally, we will mark our answer to be B.